So when we talk about diverging mirrors and when we talk about ray diagrams for diverging mirrors, what we need to understand is that there will be lots of rays that we'll have to draw behind the mirror, okay? So in this page, I don't have it specifically drawn, but obviously the front of the mirror is where this object that's given is on. So it's kind of, these little hatched lines are behind the mirror here. All right, so with your ruler, you're all going to have a ruler here. It's going to be tough for me to do this on my tablet, but with the ruler, what you're going to want to focus on is there's 3 ray rules, right? And you can use all 3 for these diagrams for most of them. But the first one is parallel focus. The second one is focus parallel. Those ones are easy. And the third one is center. So those 3. You can use all 3, and where those light rays meet, whether it's on the front side of the mirror or on the back side of the mirror, that's where the corresponding part of your image will be placed. So for example, if we use the tip of the object and I follow my rules, parallel, again, these lines are not going to be perfect, I apologize, but yours are going to be perfectly straight and parallel. Parallel and then focus. Well, here's the focus, right? And so what you would do is you would draw a line where the reflected ray would pass through the focus. So you'd draw dotted lines on the back side of the mirror, and then from the front side of the mirror on, you would extend that line as a solid line, okay? So that's the first rule, parallel focus. The second one is focus parallel. Now watch carefully. The line that would travel through the focus, okay, would go from about the object to the mirror here. Now, big no-no, please be very careful that you do not, and this is in red, so this is a no-no, do not extend this initial ray through the focus. Do not draw that part. Because remember, all the rays behind, all the rays that, that we extend, I almost lost everything. All the rays that we extend should be extensions of the reflected rays on the real side. So what would normally go through the focus would reflect parallel. So from this point, we would have a parallel reflected ray on the real side. And then we would extend that reflected ray on the virtual side, you see? Okay, so right now we have a place where 2 rays meet, and that's a good thing. Now the third ray, which would pass through the center, should be drawn as well. So here's the third ray that would go through the center, and you can see here that that line would also extend through the center. Now this is an extension of the reflected ray because anything through the center of curvature would reflect back upon its same path. So that is an extension of the reflected ray too. So you wouldn't stop there, of course. Now what you would do is you would say, okay, these rays came from the tip of the object, so that means that these rays are going to converge at the tip of the image, and the bottom of the object is on the principal axis, so you can assume that all these light rays traveling from here would extend straight through the mirror, and so the bottom would be also on the principal axis. Make a little dashed line for your image, and I think that's a perfect ray diagram there for number 1, okay? So I'm not going to do all these for you again. I'm just going to do a couple examples, but those will be all 3 ray rules for that question number 1. Any questions that you have there? Oh, I got to do characteristics here in a second. Yeah, was that your question? Yeah. So we'll do characteristics. All right, so the characteristics, I don't have spaces for them. You just have to write them somewhere wherever you can fit them. So position, so where is it? It's between F and V here. You can just say between F and V. We're going to talk about the fact that it's virtual later. So between, and there's a little abbreviation for between, B/W. I don't know if you guys use that one, but you can use that one. Between F and V, all right. The size is smaller, okay, than the object. It's noticeably smaller. The orientation, so is it upright or is it inverted? Compared to the object, it's facing the same way, both facing up, so that is upright. And here we'll say whether it's real or virtual. The image appears to be forming behind the mirror, so that is virtual. Okay, so after discussion, we have decided that we're going to go with the memory mnemonic of crops. So C is the characteristics. We want to remember C is characteristics. The position is the P here, and it can go in any order, obviously. R is reality, so there's R. O is orientation, there's upright. And what's the other one? S. S is size. So crops, we're going to get that. That's we're going to remember for characteristics. All right. I'll do the second one, and then I'll leave the third and fourth one for you guys. I will grade your efforts on that, but these ones I'm doing the exact same questions for you, really. Okay, so let's go from the tip of the object. We are going to have to do tip and the base of the object because the base is not positioned on the principal axis. Yeah. Yeah, well, now you know that. Now I'm telling you. Okay, awesome. All right, so rules. Parallel, focus. Yeah, is it the same? Yeah. Parallel, remember, every part of the object, all light rays from every part of the object will obey all the rules all the time. Yeah. We've only been using a few rays from one part of the object to state where the image is, but now we'll have to do two at least. So parallel, focus. So an extension of the reflected ray here. Awesome. Focus and parallel. Whoops, that's solid on this side and dotted on this side. Okay, so we have an idea, looks like where the top's going to be already. The center one should work really well here as well and should go right through this same spot. And so here's our tip. Now, the base of the object, we do have to figure that out because it's not going to go all the way to the principal axis, right? Okay, but let's find out where the base is. Now, is the base going to be down here? Like, is it going to be this way, you think? Or is it going to be this way? So is it going to be upright or inverted? I don't know. Let's see. Let's just see. So I'll use red for this one for the bottom. So parallel. Again, you're using a ruler. And focus. So what would pass through the focus? That's the one we draw. And focus. Parallel. And then center. Oops, that's not going to work. Okay. So yeah, there's a lot of lines there, but you can see, and I'll zoom in a bit here. If you do this with a ruler, yours is going to be awesome. Mine's kind of terrible. But they kind of converge right about here. Okay, all three of them right about there. So there's where the base of your image is going to be. So object is over here. I'll outline that again, excuse me, in black. And the image will also be in black. And it looks like the top is here, so I'm going to put the arrow facing down, and the base is here. So that's your image. And here's your object. All right. So yeah, so you got to do another set of rays here, and it's going to get a little complicated, but you'll be fine. So you do the same thing for these other ones, these last two, okay? And I think most of you should have that done. Oh, characteristics. So let's do our crops. Okay, so characteristics. Okay, R, reality, okay, is what? Is it real or virtual?
It is virtual.
It's virtual. O, orientation, upright or inverted? Is it, again, it's facing down, but it's the same orientation as the object, so that's what you compare to. So this is upright. All right. P, position, is behind the mirror between F and V. Okay, and you can say behind the mirror too. I would encourage that. Behind mirror, the virtuality of that nature is going to be, right? Oh, this has disappeared. This is not good. Behind mirror between F and V. Sorry? Yes, that's what I just mentioned. Yeah. Virtual does explain that, but behind the mirror between F and V is very clear. So I would encourage you to do that as well. And S, the size, is it larger or smaller than the object? Smaller.
What's V?
Well, V would be the vertex here. That's the point where the mirror hits the the principal axis. Principal axis is not an actual thing, it's an imaginary line, but this is V here. Here's F over here, and here's C over here. Yes? Say again? An I in the corner. This I? Okay. I don't know what you're talking about. You're good though? It's a binder hole. Oh yeah. So this the photocopy. Yes, this is pretty high tech stuff right here. So yeah, I've got a hole punch hole there. That's not an eye. Oh, I see. I see. You thought that was an eyeball. Oh yeah, an eyeball. Lashes. I see. No, that looks like an eyeball, but that's pretty good. Actually, that we could include that in here because how does your eye see this? But the eye's behind the mirror, so it's not going to work for this one. But if the eye was over here, eyeball. Yeah, we could do that, but we won't.
It's a
We won't.
two-way mirror. No. How do
Yeah.
two-way mirrors work?
How do two ways mirrors work?
I think.
Well, that should have been, I think, in your in the applications in your textbook that you would have made notes on. Remember?
I did that.
Don't forget about those applications in your notebook. Okay, so yeah, so you guys do the last two. Any questions?
Hand it in once we're done.
Yes, once you're done, please submit it. That and we'll move on. All right.